Hello everyone, welcome back to my channel, and in this video I am going to explain you how you can use FAISS indexing with Azure SQL DB. So let's say you have some data in your Azure SQL DB and you want to perform similarity search on it. So for that purpose I am using FAISS, and if you don't know what is FAISS, it is a Facebook AI similarity search, which is an open source library, and it is very well built for building an index and perform searches with a remarkable speed and memory efficiency. So if you don't want to go for the paid solution, FAISS could be your one solution wherein you can utilize this library to generate index and then further query those embeddings. So that is the reason I am going with the FAISS today. And another thing is, rather than using some paid model like OpenAI or Azure OpenAI, this time I am going to use an open source transformer model. So this video is for those who are very much looking forward to reduce the cost of their chatbot and still want to utilize the powerful features of indexing and the transformer models. So let's quickly get started with it. So I have already written few lines of code here, and the very first thing I am going to do is I have installed all these packages in my virtual environment. And once these packages are installed, what you need to do is you need to import these libraries. So it's NumPy, Pandas, FAISS, and Sentence Transformers, and then PyODBC. So PyODBC is used because we are going to get the connection from Azure SQL DB and put it over here. So the connection which we are going to take is ODBC in this case. And here I am setting up my connection strings. Then I am just reading the SQL data. So these 5 lines are doing that for me. So let me quickly show you first of all the Azure portal and my database. So let it load. Let me go back again, and this is my SQL database which I hosted in West region. It's going to take few seconds. Okay, never mind. Let's go to the query editor. Oops, it's also taking time. I will quickly refresh it. So it got loaded. Let me quickly show you. So right now, for demonstration purpose, I have taken just one table, and it is movies and series. So I have gathered some data from the Kaggle and push it into this table. So I haven't taken as it is, but I have just shortened it a bit and taken only the 35 rows from it. So this is the table, and these are the columns which I am having in this particular table. So that's all from the SQL side. So once you have done this setup, what you can do is you can go back to the code, grab your connection string, and use PyODC to get it connected. So once it is connected, we can go ahead and write our SQL queries. So in my case, the purpose or the why I'm using this particular data is I want to ask some questions based on the movies or the series and the shows and grab the output, and the output would be in the form of either the title or description, because I'm going to query only these 2 fields. So that is the reason I am taking these 2 fields. But in your case, if you are having many more fields, then you can just select all of those and grab it in this particular variable. Okay, so our SQL query is ready. Next thing is we need to grab the result from the SQL query. So for executing this, what I am doing is I am making a call to read SQL query, passing the query and the connection as well. So now this data frame is having the data which is the output of this SQL query. Now till here we are not doing anything fancy, but somebody may ask question that if we are using chatbot and we don't know SQL queries, what to do. So in that case, of course, you cannot go ahead and write this beautiful query over here. You have to get it constructed through some mechanism. So what is that mechanism? Let me quickly point you. I have already created videos on that. So this is my channel, and if you will go ahead and search for SQL Server, these are the top 2 videos which are coming up over here. So in these 2 videos, I have already explained how you can generate SQL query or how you can generate the response out of your SQL database using the natural language. So these two videos could be very useful if your database is simple. If you are having just one or two rows, then one or two tables, then you can use this one. But looks like if you are having a huge database, then I would suggest you to go with this LangChain agents, and it will tell you what is a SQL query and what is the output. So if you are new to SQL, then you can take that path. But if you are fluent in SQL, I would suggest you to directly write your query here and grab the output in this particular data frame. So let me quickly show you how my data frame looks like. Okay, so these are the columns, and I have taken just 33 rows, so it is just showing you those 33. Let's shrink it. Next thing is, like I said, I'm not going to use any paid model, rather I'm going with an open source. So as an open source, I'm using All Mini LM L6v2, which is hosted on Hugging Face. So this model is a very good transformer model, and it maps sentences and paragraph to a given dimensional vector space. So if your data is small, if you're okay with this dimension, then you can also go ahead and utilize the same model. But if you have different dimension, then I would suggest you to look for other options. So let's say if you are going with this one, then first thing you need to do is you need to get this particular package installed. And this is how you can generate the embeddings out of it. So what it is doing is, it is first importing sentence transformer. It is pushing in all the inputs. So sentences is nothing but its input data, for which it is going to generate the embedding. And this is the model instance which they are creating by passing this particular model. And this is the variable which is getting the embeddings generated by making a call to encode function. So this is the exact thing which we are doing in our code. So if you want to know why we did, then you can definitely go ahead and check this documentation over here. So I'm constructing an instance of model here. Okay, then next thing I'm doing is I'm writing a function to convert my text to the vector. So for doing that, what I'm doing, I'm just utilizing the model instance and making a call to the encode function. So this will take the input text, and it will tell you, would you like to go with the NumPy or not? So I would like to go with NumPy. I will later tell you why we are doing this. So it will go ahead and convert the text to the vector. Okay, let's go ahead and see what we are doing next. So like I said, we are interested only in the description and the title. So definitely we can just generate the vectors only for the description, because I know that my users are going to query or ask questions based only on the description. So that's the reason I'm just taking one column, but feel free to add or remove or change this column based on your requirements. So this particular function will give me the vectors values for this column, which is description. Okay, the next thing is we need to create the FAISS indexes. So for creating the index, you should know what is the dimension. Now, if you don't know what is the dimension of your data, you can directly use this line and it will tell you what is the dimension. In my case, it is 384. So either I can pass it 384 directly, or I can utilize the same dimension variable. Next thing is how you are generating the indexes. So there are multiple ways. I will point you to those. So here I am using index flat IP, but there are other options here. So these are the various methods which you can use: index flat L2, IP, or whatever you want here. And each one of these have their specific uses. So like I'm very much inclined toward cosine. So that's the reason I have used this particular index IP, flat IP. And you can see it is very good for exec search using inner product. And if you will scroll this side, you can see that it can be used for the cosine. So that is the reason I picked this one, but you can choose any one of these based on your requirement. So you can just make a note of this particular link, which is on GitHub. Okay, so let's move ahead, and the next thing here is I'm normalizing it. And why we are normalizing it? Because I want it to be used as a cosine. So again, the answer to this question, you can get it. So all these questions related to FAISS, you can get it on their documentation itself. So here it is, how can I index vectors for cosine distance? So for doing this, first of all, you need to build an index, and then you need to normalize the vector before adding it to the index. So that's the reason it is calling FAISS normalize L2. And the same thing I'm doing over here. So I'm normalizing it and then I'm adding it to my index. So now my index is having float 32 values for my description column. Let's go ahead and run this. Okay. Now we have the index. What we can do is we can simply go ahead and write it somewhere. So right now I'm writing it on my local machine. So let's run it and I can show you. So this is the folder indexes. Here I have written one CSV and one index file. So index file is the one which is holding our embeddings, and the CSV file is nothing but the data frame which we just grabbed out of SQL Server. I just pushed it into it so that we need not to query our SQL database again and again. And another important thing I want to add here is, as my database is hosting on Azure, it's an Azure SQL Server, and I don't want to query that database again and again. That's the reason I just grabbed all those results and pushed it into this data frame. So next time, whenever my users are using this, I just need to go ahead and start calling only this much of code rather than the upper one. Because now we have that index ready, we have that SQL data ready. These are the only two things which we need to answer user's query. So like I already executed it. Okay. Next thing is what we need to do is we need to load this index file and read the indexes. So this is the step which is required if you are not doing in one shot. So already we have the index here, but I'm assuming that you are calling it after some time or you are calling it in next session. So in that case, you may have to read your index file. Because if it is in the current session, then definitely it will generate as well as it will have the values in the index. But if you are in other session, then in that case you may have to reread your index file, and that's what I'm doing over here. So let's read it. Okay, here I have two important functions created. The very first one I would like to point is the search one. So what this search function does is it will take user query. It will take how many top results do you want. It will take the embedding, which is index, and it will take the model which you want to use. So these are the four parameters which you need to pass. So what it is doing here is it is taking user query and generating the embedding out of it. So this is what we are storing in the query vector. Then we are saying go to that index and search for top K results. So based on the query, it will go ahead and search top K results for us. And here in these two lines, I'm grabbing the IDs, because if you remember, we are indexing only the description part. So if you want to know what is the title of the movie, then of course you need to go back to your original data frame and grab it. So these three lines are mainly for that purpose, because here I'm calling get data, and what get data is saying is here we are passing the row number, and for that row number it is giving us the title and the description. So definitely you can tweak this code and change it as per your need, but this is the way I feel is more easier to explain. So once these two functions are done, I will go ahead and execute this cell as well, and here is the time to ask the question. So now my question is, which movie has violence? So this is the query, this is the search function which I am calling. Here I am passing in the query, I am passing in top results, index, and the model. So let's run it, and here you can say these two are the movies which are a bit violent. So let me increase it to 3. Now here you can see these movies are mainly like blood related violence and all those things. Here they're talking about that killer stuff. Here again a violent action. So definitely these results are good, but it feels like this is more violent. So this is rated as the first one. Okay, and let me ask another question which I have written it over here. And I'll just grab 2. We don't need 3. So I'm asking which movie is based on the story of Alibaba and the 40 Thieves. So this is the first movie, and this is absolutely correct. And this is again like we forced him to get the top 2 results, so it just grabbed the one which is even the rest relevant, but still it has to grab it, so it has grabbed it. But this is the actual answer which is ranked as a 1. So that's how you can query. And if I will reiterate what we have done so far and what are the benefits of this approach is, the first benefit is if your data is stored in the SQL server, you need not to query your SQL server again and again until and unless your data is frequently changing. So if your data is not changing frequently, then in that case you can grab the data once and push it into the data frame, so that there you can save some cost. Another thing is we are using open source models, so of course you need not to pay for some expensive models over here. We are using FAISS library, which is again an open source, so again we are saving some bits over there. So overall it's a good solution, and things may get more expensive if you don't know how to come up with this query, because at that point I believe you may have to spend a little bit to get some model constructed this query for you. So otherwise I think this solution is very good. Do let me know in comment if it's working for you. Thanks for watching.